I want to start with a number, not a theory, not a claim, a number 120. That is the approximate number of meters, roughly 400 feet, by which sea level was lower than it is today during the peak of the last glacial maximum, approximately 20,000 years ago. 120 meters. Think about what that means for a moment. Every coastline on Earth was different. Every continental shelf that is currently underwater was dry land. The shallow seas between islands were plains and valleys and river mouths and beaches. The geography of the planet was not what it is now. It was not slightly different. It was fundamentally, dramatically, unrecognizably different in terms of where the land was and where the water was. And then, between roughly 20,000 years ago and about 7,000 years ago, the ice melted, the sea rose, the land that had been dry for tens of thousands of years went under. And it has been under ever since. I want to ask you to hold that image before we go any further, not as an abstraction, not as a geological event that happened to someone else a long time ago. As something that happened to real land, land that had real geography, real rivers, real coastlines, real soil, real ecosystems, real everything that land has. That land exists today. It is under the ocean. It did not dissolve. It did not disappear. It went underwater and it is still there on the floor of the continental shelves, around every continent on Earth. And it has been sitting there for between 7,000 and 20,000 years, and in some places longer. And the question I want to ask, the question I cannot stop asking, is what was on it, not what lives on it now. What was on it before the water came? What was the geography of a world in which the land extended hundreds of miles further in every direction than it does today? What was growing there? What was moving across it? What was happening on the land that is now the shallow seafloor, and what traces of all of that are still down there, waiting? Let me give you some specific geography because I think the specific is more powerful than the general here. Look at the continental shelf of Northwest Europe. The shallow sea between Britain and the European continent, what we now call the North Sea, was not a sea during the last glacial maximum. It was a plain. A vast, flat, cold plain through which rivers ran from what is now Scandinavia and Britain down toward a coastline that was hundreds of miles further north and west than the current coastline of Norway. There was a river system called Doggerland by the geologists who have reconstructed its geography that drained much of what is now the southern North Sea basin. The rivers that we now know as the Thames and the Rhine and the Scheldt and the Elbe did not empty into the sea separately. They converged in this lowland plain and flowed together toward the north. The plain they crossed was not featureless. It had hills and valleys and lakes and marshes and forests and the animals that lived in all of those environments. Woolly mammoths, aurochs, horses, the full megafauna of the late Pleistocene European landscape, living and moving and dying on ground that is now under 60 meters of the North Sea. We know this because trawlers fishing in the North Sea have been bringing up bones and teeth and occasionally artifacts from the seafloor for over a century. A bone of a woolly mammoth dredged from the Dogger Bank, a worked antler tool, a barbed point made from bone, objects that were made or used by people on land that is now under the sea. Those objects are real, they are in museums, and they are the visible tip of something much larger that is sitting on the seafloor and that we have barely begun to examine. What I keep asking when I think about Doggerland is not just what was there, but how much of it is still there to find. The shallow seafloor of the North Sea has been disturbed by trawling and by oil and gas exploration and by the installation of wind farm infrastructure. All of that disturbance has produced incidental finds, the bones and tools and organic material that come up in nets or are uncovered by construction. But systematic archaeological and geological investigation of the submerged landscape, the kind of comprehensive survey that would map the ancient river channels and lake beds and habitation sites and give us a real picture of what Doggerland was, that has barely begun. The technology exists. High-resolution sonar can map the seafloor in extraordinary detail. Sediment coring can recover organic material and pollen and plant remains and animal bones from the ancient land surface buried under the seafloor sediments. Ground-penetrating seismic surveys can reveal ancient river channels and lake basins buried meters below the current seafloor. All of these tools exist and have been applied in limited ways to small areas of the North Sea. The scale of what remains to be done is enormous, and the scale of what might be found is something I find very difficult to fully imagine. Now extend the same thinking globally. Doggerland is the best studied example of submerged prehistoric landscape because it is shallow, relatively well mapped, in a heavily trafficked sea, and adjacent two countries with strong traditions of maritime archaeology. But the same phenomenon, land that was above water during the glacial maximum and went under when the ice melted, exists on every continental shelf in the world. The shelf between mainland Asia and the islands of Southeast Asia, called the Sunda Shelf, was a landmass nearly twice the size of India during the glacial maximum. Two rivers, roughly equivalent in size to the Amazon, flowed across it toward the deep water edge. The land connected what is now the Malay Peninsula to Borneo and Sumatra and Java, and the strait between that landmass and what is now the island of Australia was far narrower than it is today. The Sahel Shelf connecting Australia to New Guinea was also partly exposed. The coastline of what is now Australia extended hundreds of miles further out to sea. The first people to reach Australia, whose descendants became the Aboriginal Australians of today, arrived by water, but they crossed a much smaller stretch of open sea than exists now, and they landed on a coast that is now underwater. The land they first walked on in Australia, the beaches and coastal plains where the first Australians made their first campsites, is under the Indian Ocean. It has been underwater for somewhere between 40 and 60,000 years. And we have essentially no idea what is there. I want to stay with the Sunda Shelf for a moment because I think it is the most striking example of what has been lost in terms of sheer scale. The Sundaland mass at its maximum extent was a continuous land bridge connecting the entirety of what is now the island archipelago of Southeast Asia into a single continuous territory. The rivers that crossed it were among the largest river systems on Earth at the time. The lowland forests that covered it would have been among the most biodiverse habitats on the planet, in the same ecological zone as the rainforests that still exist on the higher elevation interiors of Borneo and Sumatra. Animals moved freely across it. People moved freely across it. Whatever cultural and biological history of human occupation exists for that region during the period from roughly 70,000 to 10,000 years ago happened primarily on land that is now under the Java Sea and the South China Sea and the Strait of Malacca. The archaeology of Southeast Asian prehistory for that entire period is mostly on the seafloor. The sites where people lived, made tools, buried their dead, and developed cultural traditions, those sites are underwater, and we have found almost none of them, not because they are not there. Looking for them requires technology, resources, and institutional will not yet applied at the scale this problem requires. Here is what I find most striking about this situation. We have been doing archaeology on land for hundreds of years, excavating ancient sites on every continent. We developed techniques of extraordinary sensitivity for finding and extracting information from traces ancient people left. Yet the majority of human prehistory's archaeological record, when modern humans spread, is underwater, not lost, not destroyed underwater. Still there under sediment accumulated since the land went under. Preserved by the cold, the dark, and the absence of disturbance that destroys sites on land, preservation conditions on the seafloor are in many ways better than on land. Organic material survives longer, sedimentary sequences are less disturbed. The cold of deep water slows biological processes that break down organic material. The sites are there, sometimes better preserved than land equivalents, and we have barely looked. The question of why we have barely looked is one I find genuinely interesting, and I do not have a complete answer. Part of the answer is practical. Underwater archaeology is expensive, requiring specialized equipment, training, and logistics. The cost per square meter is dramatically higher than on land, and the area to be investigated is vast. The submerged continental shelves cover an area comparable to the entire African continent. Surveying that area comprehensively with the resolution needed to find sites is a project whose scale is almost incomprehensible, but expense and scale alone do not fully account for the gap between what is there and what has been investigated. We spend large amounts of money investigating difficult and expensive things. We build space telescopes. We drill into the ocean floor in the deep sea. We send submersibles to the deepest trenches. When something is considered important enough, the resources are found. Why has the submerged prehistory of the human species not been considered important enough to motivate that kind of investment? I do not have a satisfying answer, but the question itself feels important. Now I want to go somewhere more specific, to a particular feature on the continental shelves that deserves attention. When river systems exist on land, they don't just flow across the surface, they cut into it, carving channels and valleys. Those valleys persist in the landscape long after the conditions that created them change. Ancient river valleys are visible as topographic features reflecting former river courses, even if they've changed or disappeared. On the continental shelves, the same process applies. When the shelves were dry land, rivers cut channels. Those channels are now on the seafloor, buried under marine sediment or visible depending on accumulation. High-resolution sonar surveys of continental shelves worldwide reveal extraordinary ancient river channel systems. Off Florida, channel systems drain toward the deep Atlantic, carved when those channels were on dry land. Off northwest Europe, ancient Rhine-Thames river system channels are visible as depressions in the North Sea floor. Off India, ancient river systems drain across the exposed shelf toward what was then the Arabian Sea coastline. Off Australia, ancient drainage systems cross the continental shelf in directions that make no sense now, but made sense then. These river channels are not speculative. They have been mapped. They are in the scientific literature. They are the veins and arteries of a landscape that existed and is now underwater. And where there are rivers, there are the places people lived, because people follow water. People settle near rivers. Sites of ancient habitation are in river valleys, on river banks, at confluences, and river mouths. All of those places, for the period we are talking about, are on the seafloor. I want to ask about something I think is even more interesting than habitation sites, the coastlines themselves. Not ancient coastlines as abstract geographical lines, but what coastlines mean as environments. A coastline is the most productive habitat on Earth in terms of food resources per unit area. The interface between marine and terrestrial environments produces resources neither environment alone provides. Shellfish beds, estuarine fisheries, migratory bird populations, marine mammals that hole out on beaches. The mixing zone where freshwater rivers meet the sea creates particularly rich estuarine ecosystems. Archaeological evidence from coastal sites above water consistently shows coastal dwellers had diverse, richer, more reliable food supplies. The coastal adaptation was not just one option. It was often the richest and most sustainable way to live. The world's coasts during maximum glaciation were not where current coasts are. They were hundreds of miles further out to sea. The richest habitats, most productive environments, places supporting large human populations during critical development are on the seafloor. And I keep asking, what is there? Not just bones and tools, though those are there. What is the full picture of what human life on those coasts looked like? What were people doing? How were they organized? What did they build that might have survived submergence and is still there? There are specific locations where this question becomes particularly pointed. The Persian Gulf is currently a shallow sea, mostly less than 100 meters deep. During the glacial maximum, it was not a sea at all. It was a valley, a river valley, through which a large river flowed from what is now the head of the Gulf toward the Strait of Hormuz and into the Indian Ocean. The valley was surrounded by highland terrain on both sides, fed by rivers from what is now Saudi Arabia, Iran, and Iraq. The climate during this period is debated, but evidence suggests parts of the Arabian Peninsula had significantly more rainfall. What was the Persian Gulf Valley like during those wetter periods? What lived there? What grew there? What moved through it? These are not abstract questions. The Persian Gulf floor is one of the most extensively surveyed seafloors in the world. This is due to oil and gas exploration. High-resolution seismic data from that region is abundant. The ancient river channel system is visible in that data, but a systematic examination for archaeological records has not been done. Not for oil, not for gas, but for what was living there. That examination has not happened at the scale it deserves. Let me ask something that brings this to its sharpest point. Modern human behavior, with its complexity, appears in the archaeological record, roughly between 100,000 and 50,000 years ago, depending on where you look. This behavioral development happened somewhere, in specific places where populations were living and developing practices. The geography of the world during that period was different. Coastlines, rivers, and landscapes were all different. The richest environments, most likely to support these populations, were often on land now underwater. The record of human behavioral origins is partly on the seafloor, maybe mostly on the seafloor, and we do not know because we have not looked. I find that fact almost unbearable to sit with. The most important question in human prehistory has a significant part of its answer on the floor of the continental shelves. In cold, dark water, under marine sediment, preserved and waiting, and we are looking at other things. I want to close with something that is both the most concrete and the most open-ended part of all of this. The ocean is not static. The ocean floor is not fixed. Sediment accumulated on continental shelves is not a permanent seal. In places, currents disturb the seafloor and expose older sediment. Trawling equipment disrupts stratigraphy. Natural processes of erosion and deposition create windows into older layers below, and occasionally something comes up that was not supposed to be there, a bone too old to be marine. A shaped piece of stone from a layer that should contain nothing but marine fossils, an organic structure not naturally occurring in a marine environment. These finds are not common, but they are not absent. They appear in scientific literature if you know where to look, in records of trawler captains and offshore crews, who bring up things they did not expect and file them in reports that rarely reach the mainstream. The finds are there, the signals are there, the seafloor is not a blank. It is a buried landscape full of the record of everything that happened on it when it was above water. And the question of what that record contains, what it would tell us about where we came from, and what we were before the sea rose and covered the world we lived in, that question is as large and open, and as unanswered as any question I know. The water rose, the land went under, the record is still there. And I think it is time we went looking for it with the seriousness it deserves. There is a concept I want to introduce here that changes how you look at the ocean when standing on a coast. The concept is called the continental shelf. You probably know it in the technical sense. The shallow underwater extension of the continent that drops off at the shelf edge into deep water. But I want you to think about it differently. I want you to think about it as land, because that is what it is. Not metaphorically, not geologically in some abstract sense. It is land currently submerged. The rock under the shallow coastal seas is continental rock, geologically identical, geologically continuous. The ocean did not create it. The ocean covered it, and the coverage is recent, geologically speaking. The current high sea level, under which we built our civilization, is not the normal sea level of this planet. It is a high stand. We are living in a period of unusually high sea level relative to the average. The average sea level over that period is significantly lower than today. The world we know with its current coastlines is an anomaly. The world with more land, with continental shelves exposed, is closer to the average condition of the planet. We built everything we have on an anomalously high sea stand. The world that was normal before is underwater. I want to ask what this means for how we think about the human story. The standard narrative of human prehistory is built around the geography we have now. It places ancient populations in the interiors of continents, in highlands, in river valleys of modern landmasses, because those are the places where we have found the archaeological record. And we found the record there because those lands have been accessible to investigation. But the places where the record might be richest, coastal lowlands, estuarine environments, the productive interfaces between land and sea, those places are most affected by sea level rise. They are the places that went under first and went deepest, so the archaeological record we have is biased. It overrepresents places that stayed above water and underrepresents places that went under, and the places that went under are exactly where human populations would have been most attractive. The bias runs in the direction of hiding the most important evidence. Consider what this means for a specific question that has puzzled archaeologists and anthropologists for a long time. The question of why modern human behavior appears to emerge so suddenly in the archaeological record at certain times and places. Earlier periods show simpler technology and less behavioral complexity. Many explanations exist for this pattern, but what if the apparent suddenness of the behavioral transition is partly an artifact of the bias in our sample? What if populations developing complex behaviors lived on coasts, in rich environments, and those coasts are now underwater? What if the gradual development we expect is there, but on the seafloor, and we haven't found it? What if the transition looks sudden because we only see later stages, after populations moved inland or to higher coastal environments? The earlier stages are under the ocean. This is a possible explanation that current evidence cannot rule out. Getting that evidence would require a scale of investment in underwater archaeological survey that has not been made. Here is another specific geography, the Black Sea. It is connected to the Mediterranean through the Bosphorus Strait. During the glacial maximum, it was a freshwater lake, fed by rivers, with a water level significantly lower than today. The land around it was dry. The shoreline was far below the current shoreline of the Black Sea. Then the Mediterranean water level rose, breaching the Bosphorus, and salt water poured into the freshwater lake. The timing and nature of this event is scientifically debated. Some suggest a gradual process, others a rapid, major flooding. What is not debated is that the ancient freshwater lake's shoreline is now under the Black Sea. The land around that ancient shoreline was occupied by human populations for thousands of years before the flooding occurred. Ancient settlements, campsites, fishing sites, burial grounds. The full material record is on the floor of the Black Sea. The Black Sea is unusual because it is anoxic below a certain depth, oxygen-free. In an anoxic environment, organic material survives almost indefinitely. Wood does not rot. Leather does not decay. Textiles do not dissolve. The preservation conditions on the deep floor of the Black Sea are extraordinary, comparable to the most famous dry archaeological sites, and what is preserved there, if there is anything to be preserved, has not been systematically investigated. I keep asking about the gap between what might be there and what has been investigated. The gap itself seems significant. We have underwater archaeological research programs. We have the technology to investigate deep seafloor environments. Yet the investigation of submerged prehistoric landscapes as a systematic enterprise does not exist at the scale the question requires. Individual projects examine individual sites. Specific surveys cover specific areas, but a comprehensive, globally coordinated program has not been organized. I keep asking why, and I keep arriving at an answer that is unsatisfying but may be accurate. The question has not yet been taken seriously enough at the institutional level to generate the priority and funding. The question is considered interesting. It is not yet considered urgent, and I think there is a case to be made that it is urgent. Not because of what we might find, but because of what we are losing. The seafloor is not static. Trawling disturbs it. Offshore construction disturbs it. Natural erosion and sedimentation processes alter it continuously. Every year that passes without systematic investigation is a year in which the record is further disrupted and degraded. The window is not permanently open. It is closing slowly, but it is closing. What we do not investigate before it closes is gone forever. I want to end with the image that I think captures this best. Stand on any beach in the world, look out at the water. What you are looking at is not the edge of the world. It is the edge of what is visible. The world continues under the water. The land under those waves, under those depths, is as real as the land you are standing on. It has the same geological substance. It had, until recently in geological terms, the same biological productivity. It had rivers and forests and animals and weather and everything else that land has, and people who were born on it and lived on it and died on it, and whose descendants in some cases are us. The water did not erase their world. It covered it, and it is still there, under the sea, in the cold and the dark, under the sediment that has been falling on it for 10,000 years. The rivers they drank from are still there as depressions in the seafloor. The hills they climbed are still there as underwater topography. The beaches they walked on are still there as layers of sand. And somewhere in all of that, in some layer, in some sediment core that has not yet been taken, in some seafloor survey that has not yet been done, there is a record of what they did and who they were and what they left behind. I do not know what that record contains. Nobody does. That is exactly the point, the most important library in the world is underwater. Most of it has never been opened, and the question of what is in it is the question I cannot stop asking. The sea rose and covered the world we came from. The world is still there, and I think it is time we went to look.